Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. Understanding when and where GFCIs are required is crucial for ensuring electrical safety in residential and commercial buildings. The implementation of GFCI requirements has evolved over time, with specific dates marking when they became mandatory in certain areas. Let's delve into the timeline of GFCI requirements, covering various locations. In bathrooms, GFCIs were required in all new constructions starting in 1975. The requirement expanded to all existing bathrooms during remodeling in 1990. By 1996, all existing bathrooms with a tub or shower needed GFCI protection. For garages, the mandate for GFCIs in all new construction began in 1987. Subsequently, in 1996, all existing garages with an electrical receptacle were required to have GFCI protection. Outdoor receptacles saw the implementation of GFCI requirements in 1978 for all new construction within 6 feet of water. In 1990, all existing outdoor receptacles within 6 feet of water were mandated to have GFCI protection. Kitchens saw GFCIs required in all new construction for receptacles within 6 feet of a sink starting in 1975. In 1996, all existing kitchens with a sink, specifically receptacles within 6 feet of the sink, were required to have GFCI protection. Unfinished basements had GFCIs mandated in all new construction beginning in 1987. Subsequently, in 1996, all existing unfinished basements with a finished area were required to have GFCI protection. Crawl spaces had GFCIs required in all new construction starting in 2005. By 2008, all existing crawl spaces undergoing remodeling were required to have GFCI protection. Other areas also have specific GFCI requirements. Laundry rooms and utility rooms required GFCIs in new construction beginning in 1975. Boat docks and swimming pools and spas required GFCIs in new construction starting in 1990. These dates provide a general guideline for when GFCI protection became mandatory in different locations. However, it is important to note that local building codes and the specific requirements of each jurisdiction may vary slightly. Consulting with local authorities is always recommended to obtain the most up-to-date information and ensure compliance with all applicable regulations. The purpose of a GFCI is to protect people from electrical shock. It does this by monitoring the current flowing through a circuit. If the current flowing into the circuit differs from the current flowing out by a small amount, as little as 5 milliamps, the GFCI will trip and quickly cut off the power. This difference in current indicates that some of the current is leaking to ground, possibly through a person. Regular circuit breakers are designed to protect against overload and short circuits. They do not detect small leakage currents that can cause electrical shock. GFCIs are specifically designed to detect these small currents and trip quickly, preventing serious injury or death. GFCIs are required in locations where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor areas. The presence of water increases the risk of electric shock, making GFCI protection essential in these areas. The 6-foot rule, often mentioned in relation to sinks and water sources, specifies the distance within which GFCI protection is required for receptacles. This is because the risk of electric shock is high near water sources. The installation of a GFCI is relatively straightforward. GFCIs are available as receptacles and as circuit breakers. GFCI receptacles replace standard receptacles and provide GFCI protection at that location. GFCI circuit breakers replace standard circuit breakers in the electrical panel and provide GFCI protection for the entire circuit. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. The receptacle has line and load terminals. The wires from the power source connect to the line terminals, and the wires that continue to other receptacles or devices on the circuit connect to the load terminals. It is crucial to connect the wires to the correct terminals to ensure proper GFCI protection. Testing a GFCI is essential to ensure that it is functioning correctly. GFCIs have a test button that simulates a ground fault. Pressing the test button should cause the GFCI to trip and cut off the power. If the GFCI does not trip when the test button is pressed, it may be faulty and should be replaced. GFCIs should be tested monthly to ensure they are working properly. If a GFCI trips frequently, it may indicate a problem with the circuit or the devices connected to it. It is important to investigate the cause of the tripping and correct any faults. Common causes of GFCI tripping include faulty appliances, damaged wiring, and moisture in the circuit. In addition to GFCIs, arc fault circuit interrupters, or SIs, are another type of circuit breaker that provides additional protection. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a spark. SIs are required in many areas of the home, including bedrooms and living rooms. The combination of GFCIs and SIs provides comprehensive electrical safety protection. GFCIs protect against electrical shock, while SIs protect against fires. Both types of circuit breakers are essential for ensuring the safety of occupants. Regular inspection of electrical systems is crucial for identifying potential hazards. Electrical panels should be checked for loose connections, damaged wiring, and signs of overheating. Receptacles and switches should be inspected for cracks, damage, and loose connections. Any electrical problem should be addressed promptly by a qualified electrician. Over time, electrical codes and standards evolve to enhance safety. Staying informed about the latest code changes and regulations is essential for ensuring compliance and maintaining a safe electrical system. Local building departments and electrical inspectors can provide valuable information and guidance on electrical safety requirements. Proper grounding is a critical aspect of electrical safety. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. All electrical systems should be properly grounded according to the National Electrical Code. Grounding electrodes, such as ground rods and ground plates, are used to connect the electrical system to the earth. These electrodes provide a low impedance path for fault current. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage electronic equipment. Surge protection devices, or SPDs, are designed to protect against surges. SPD are available as receptacles, plug-in devices, and whole-house surge protectors. Whole-house surge protectors are installed at the electrical panel and provide protection for the entire electrical system. Electrical safety is a shared responsibility. Homeowners, contractors, and electricians all play a role in ensuring electrical safety. By following electrical codes, using proper installation techniques, and maintaining electrical systems, we can prevent electrical accidents and protect lives. Electrical safety training is essential for anyone working with electricity. Training programs cover a wide range of topics, including electrical codes, safety procedures, and troubleshooting techniques. Qualified electricians have completed extensive training and have the knowledge and skills to perform electrical work safely and correctly. When hiring an electrician, it is important to verify their qualifications and experience. Check their license and insurance and ask for references. A qualified electrician will be able to assess your electrical needs and provide safe and reliable solutions. Do not attempt to perform electrical work if you are not qualified. Electrical work can be dangerous and mistakes can have serious consequences. Always hire a qualified electrician to perform electrical work. Electrical safety is not just about preventing electrical shock. It is also about preventing fires. Electrical fires can be caused by faulty wiring, overloaded circuits, and misuse of electrical equipment. By following electrical safety guidelines, we can reduce the risk of electrical fires. Smoke detectors are an essential part of fire safety. Smoke detectors should be installed on every level of the home and in every bedroom. Test smoke detectors monthly and replace the batteries at least once a year. Carbon monoxide detectors are also important for detecting carbon monoxide, a colorless and odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas. Electrical safety is a continuous process. It requires ongoing vigilance and attention to detail. By staying informed, following safety guidelines, and maintaining electrical systems, we can create a safe electrical environment for ourselves and our families. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for specific electrical safety recommendations. Remember, electrical safety is paramount. By taking the necessary precautions, we can protect ourselves and others from electrical hazards. It is important to routinely check the condition of extension cords for any damage such as fraying or cracking. Damaged extension cords can pose a significant fire hazard. Never overload extension cords or outlets. Overloading can cause the wires to overheat and potentially start a fire. Use extension cords only temporarily. For permanent electrical needs, install additional outlets. Keep electrical cords away from water and heat sources. Water and heat can damage the insulation on electrical cords and increase the risk of electrical shock or fire. When unplugging an appliance, always grasp the plug, not the cord. Pulling on the cord can damage the wiring and create a safety hazard. Avoid running electrical cords under rugs or carpets. This can trap heat and damage the cord, increasing the risk of fire. Use child safety plugs and unused outlets to prevent children from inserting objects into the outlet. Teach children about electrical safety and the dangers of electricity. Ensure that all appliances are properly grounded. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. If an appliance has a 3-prong plug, do not remove the grounding prong. The grounding prong is there for your safety. If you need to use a 2-prong outlet, use an adapter that properly grounds the appliance. Be aware of the location of overhead power lines when working outdoors. Maintain a safe distance from power lines to avoid electrical shock. Never use electrical appliances near water. This includes radios, hairdryers, and other electrical devices. If an electrical appliance falls into water, do not reach for it. Turn off the power at the breaker and then retrieve the appliance. Call 911 if you see someone in contact with electricity. Do not touch the person until the power is turned off. Learn basic first aid for electrical shock. This includes knowing how to perform cardiopulmonary resuscitation, or CPR. Take an electrical safety course to learn more about electrical safety. There are many resources available online and in the community. Electrical safety is everyone's responsibility. By following these guidelines, you can help to prevent electrical accidents and protect lives.